Okay, we'll go ahead and get started. So first, I have a couple of questions. How many of you guys have your kits came in?
Mine did. Mine and Laura's.
Okay, good. Adam, did yours come in? You can, if you can't talk, just enter the chat. Okay, good. Good. Okay. So next week we'll be starting up the labs. We'll probably, we're gonna have to go through the inventory and stuff like that. I'm gonna send you guys a message. I'd like you guys to do that independently. And then the very first lab that you guys are gonna be doing, and it won't be up until that last person gets their kit, and then we'll have it up and running for you guys. Okay. We've also are trying to work out some kinks that we're having in the Canvas shell so that it's not taking you guys to the right place to actually do the lab. So you guys aren't able to see it. So we're working those out as well too while we're waiting for that last kit to come in. And I don't know if that's intentional by the company or what. So the other thing that I wanted to share with you, I will be putting up tonight your group project. So the rubric for your group project, it'll be official. So there'll be a very general intro to the group project, and then it'll be broken down to the individual parts. So you guys know that there are 4 parts to your group projects. It's the parody, it is the presentation, it is the parody presentation, and the page and the peer review. And I've kind of gone over it before, but I will also have a video in the introduction of the group project. And your groups have been formed. You should be able to see them if you guys look on your Canvas shell. Let me confirm that first. If you go to your Canvas shell and yeah, so if you go to your Canvas shell, you should have a little area under that main menu where it says account, dashboard, courses, and then under that, you should have groups. And so you should be able to see your group and the people in your group by selecting group. And you want to make sure you select the one that's for chemistry. And so it'll say 2 things. It'll say your topic, and it'll say your genre. Okay. Questions?
Wait, say that again. Where do we go?
So let me share my screen so you guys will be able to see it. Okay, so if you guys look on my screen, can you guys see it? I don't know if it's popping up. There you go. Right here, it'll say groups. So you're going to go ahead and select your groups. So for instance, Layla, you are in dimensional analysis and your genre of rap is going to be old school rap. And then these are the people that are in your group.
Dr. Henry, I don't have access to that group section.
You can't see it. It's under people.
Okay.
If you go under people, and for us, we can't go into the group section because you're not part of a group. They can see it because they're part of a group.
Okay. Good to know.
And I'll show you how we can see it later. So if you guys scroll down, you'll see, well, if you select your group, you can go in there and then you can see all the people that are in your group. And then you'll notice that there are pages. So let me give you an example. So let's go into dimensional analysis group. So when you click it, it'll show up like this when you select your group. And then, so the very first part is your home page. The next part is the announcement. So in the case of your announcements, you're sending announcements to everybody that's in that group. Okay, so you can send announcements there. This is your page right here. So this is what I mean about a Canvas page. And like I said, I'll go over it in more detail. But when you're getting ready to establish your Canvas page, which has to be minimal, well, it has to be 2,000 words. You're going to go ahead and hit that topic. You'll give it a title, and then this is where you're going to do all your typing. Now you'll notice you have a lot of formatting cues and keys up top. And so you want to make sure that you're using your formatting key. So for instance, let's say I was talking about I was talking about writing a chemical equation. And so I was making water. And then I want to say it yields, right? So if I want to make that arrow for yield, I'm going to go here to insert mathematical equation. And then there's a tab that says arrow. So then I can select the arrow that I want to use. I want to use a big yield arrow. So let's see if this one looks good right here. So I'm going to go ahead and put that one in there. Okay. Now we also have superscripts and subscripts that we use in chemistry. So this is where we're going to do our superscript. This is where we would do our subscript. Okay, and then when you want to get out of it, you just select superscript again, and it'll put it back to normal. Okay. And so what I recommend that you guys do is just play with it a little bit to kind of get used to it. So you kind of get a feel. Okay. And I'll delete what I wrote on your page so it doesn't show up. Dimensional analysis. Okay. So as I was saying here, the people, this is how you determine the people that are in your group. So this here is the people in the groups. This here gives their email addresses for the class. So you're able to sit there and communicate. This here is where you guys can start a little discussion board for your group. And then any files that you guys want to share with each other, you can upload them here. So you just drag the files over and then you just put them there, or you can choose the file that you want to upload. I don't know what the big blue button's for. Yeah, it's not what you guys are going to need it for. Okay. And then, and you're not going to have to worry about doing, this is if you want to do collaborations, you can actually do it through your group section. So you guys can share a Google Doc. So you guys are collaborating on a Google Doc. And so, but you guys need to have access to everybody's Google Docs. Okay? Okay. So unfortunately, we'll be doing LabSir again today. Are there questions? I like it when there are questions. Let's see, we got our lab kit. Let's see, our school. Okay, thank you, Adam. Okay, so you got the one that I dropped off? Is that what you're saying? Okay, are there any other questions? Okay.
When's the exam due?
The exam is due on the 22nd at 11:59 p.m. So since I extended it, make sure you guys get it done. Okay. And you have two attempts. So if you've already done one attempt, you have a second attempt to improve your grade. Okay. I typically don't do that, so take advantage of my kindness. Okay. I will let you guys go and go ahead and get started. So I will see you later, Israel.
Yep.
And I'll show you how to maneuver through the groups and everything too. So let's see. Oh, I also forgot one other thing. So if you're not able to always make this one, we'll be doing a recap of the lab that you guys did on Mondays. So Israel's is going to be like the first day for lab, and then next Monday will be the last day for lab. Okay. So I will see you guys later. Have a good day.
Yeah.
Have a good one. Okay. Another easy day today. Like Dr. Andrews said, that there's issues with the whole science site that are preventing us from doing labs like how we wanted to. So another Labster lab. Yay. It's under modules as week 5, I believe. Week 4. So it's right here. Atomic structure. I think the gist of this one is that we're going to be going over the atom itself, what comprises of an atom, and just other subtopics regarding atomic structure. So just like the other ones, you guys are more than welcome to go ahead and leave and do this on your own time. If not, I'll be going through the entire thing right now. So yeah, this is all we're doing this week for lab. So any questions?
Do you still have the tutoring on Thursdays?
Yes, I do. So to access that, it's under announcements and it's right here. And just click on this link. So from 7 to 8, I'll be
And
tutoring.
Would you like review the practice test with us?
Yeah, I can go over the practice exam with you guys.
Okay.
So yeah, every week on Thursday, 7 to 8. And if you or if you missed the chance to go to my tutoring, Angelia is also tutoring this week. And she has more hours available than I do. So we've got more or less every day covered. Any more questions? Layla? Okay, I'm gonna get started with the demo. Hey, things we will learn: explaining the concept of an atom, the properties of the basic subatomic particles, protons, neutrons, and electrons, defining the atomic number and the atomic mass, defining what are isotopes, and understanding the basics of the quantum atomic model.
Hi there, welcome to Labster. Today you will learn about the components of atoms. Are you ready to see inside the atom? If everything goes well, you may be part of a very important mission about life itself, but it is too soon to know yet. This simulation uses voiceovers. If you don't have audio, click the speaker symbol on the top left of your lab pad Using the lab pad is an important way to get the most out of this simulation. Is this the first time you are playing a Labster simulation? Perfect. Then let's get started with your first mission. Find a lab coat to your left and pick it up to wear it.
Safety is priority.
Did you know that all matter is made of atoms? Approximately 99% of your body is made up of atoms of hydrogen, carbon, nitrogen, and oxygen. As for me, I am almost pure carbon and iron. Would you like to know some more facts about the atom? Option A, is this a new discovery? Option B, how small is an atom? Option C, how many atoms are in my body? Option D, what is the identity of each atom? Option E, that's all. Let's continue. The theories about atoms are as old as ancient Greece, but different models have been studied over the past few years. I have tried to summarize the great influencers of the atomic theory in this image on the wall.
So I don't think Dr. Henry is going to be asking you guys about each of these scientists. I don't think you'll be forced to learn who they are. You won't be asked questions on who they are. Niels Bohr, however, is probably a name that you'll encounter shortly, this week or maybe next week. As you do go over this thing called the Bohr model, and it's covered in lecture. So probably that name is the only one.
For more information. In order to understand how small an atom might be, compare it to a coin, and then think about how small a coin is compared to Earth. Check out the image on the wall display to visualize this better. Since you now have an idea about the size of an atom, you realize that I am not going to read all these zeros for you. They are plenty, and they can be found on the wall display in front of you. Even if you haven't heard of them, atoms consist of subatomic particles, neutrons, protons, and electrons. As your height and weight may be used to describe you, in the same way, the number of the subatomic particles are used to identify each atom from one another. Check out the wall display for more information. You seem eager to start exploring. I like that. We are going to learn so much about the atomic structure together. Enter the main lab room by clicking on it. We are going to start by learning the basic building blocks of atoms at the Atomic Builder. Click on it to go there. Time to learn about atomic structure and do things that only a virtual simulation could allow you to do. In front of you is an atom of lithium. This atom has 3 protons and 4 neutrons in its nucleus, and 3 electrons are orbiting around it. And as I really appreciate a good fun fact, although lithium is a metal, it is soft enough to cut with a knife. What are the subatomic particles of an atom? You can lower your lab pad and use the lithium structure on the holotable to help you. Option A, protons, neutrons, electrons. Option B.
So before she keeps talking, if you cut the previous table, you saw that all of these were labeled. So we know that protons are the red ones because they are positively charged. One thing to make it easier to learn this, P protons, P positive. It's a little thing, but you'd be surprised how many people tend to forget this. The ones orbiting the center are called electrons, and these are negatively charged. And these yellow ones are called neutrons. So one way to also memorize neutrons is it's kind of similar to nucleus, and we all know nucleus is found in the center of a cell, and neutrons are more or less the same. So a little tidbit to help you memorize. But let's get on to the question. What are subatomic particles of the atom? As we just discussed, protons, neutrons, and electrons. So with that,
Nice work. An atom consists of protons and neutrons located in the nucleus and electrons that are orbiting the nucleus. Click on the right arrow on the holotable screen for an atomic builder challenge. Can you create an atom with atomic number equal to 2? Click the red submit button once you think you have it correct.
atomic number equal to 2. Oh, okay.
Why don't you position the protons and electrons first? I will take care of the neutron.
That's weird. Okay, this thing's a little janky. So I would have to guess.
Great job.
Yeah.
As you have noticed, I also placed 2 yellow neutrons in the nucleus, and now what you have is the atom of helium. I won't be doing many things for you later on as you become an expert in atomic structure.
An expert.
An atom with an atomic number equal to 2 has 2 protons in the nucleus, and since the charge is neutral, there should also be 2 electrons. The number of neutrons is not of concern at the moment, as we're building a random atom. Click on the right arrow of the holotable to proceed to the next atomic build challenge. Can you create an atom with mass number of 3 and a neutral charge? Click the red submit button when you think you have it correct. A mass of 3 means that there are 3 subatomic particles in the nucleus. Since this atom is neutral, that means that the number of electrons orbiting should be equal to the number of protons in the nucleus. Good job. An atom with a mass number equal to 3 means that there should be a sum of 3 neutrons and protons in the nucleus. In this case, there should be either 2 protons and 1 neutron, or 1 proton and 2 neutrons present in the nucleus. Since the charge is neutral, there should be as many electrons as protons. And a fun fact, the only nucleus without neutrons is the nucleus of hydrogen that has only 1 proton. Click on the right arrow of your holotable to try a new atomic build challenge. Can you turn the atom you created into a cation? Click the red submit button once you are done.
Interesting that it's asking to do cations now. So I guess I should say what that is. So when talking about atomic structure, you'll be tasked with learning the phrase cation and anion. So a cation is something that is positively charged. One way to memorize this is the T in cat ion. It's kind of silly, but the T kind of looks like a plus, and that's how I memorized it. So knowing that a cation is positively charged, we can distinguish that an anion is going to be negatively charged. So yeah, they're more or less opposites of one another. So remember, cation positive, anion negative. So we had to make this structure positively charged. So since 1 electron and 1 proton equal a neutral charge, we can just go
Try
ahead
changing the number of electrons that orbit the nucleus. This way, you ensure that the mass number and atomic number remain unchanged. What is the atomic number of a neutral atom that has 5 neutrons and 4 electrons? Option A, 5. Option B, 4. Option C, 1. Option D, 9.
atomic number of a neutral atom that has 5 neutrons and 4 electrons. Since we know electrons equal to the same amount of protons, and this atom has 4 electrons, we can say that.
Absolutely. The atomic number describes the amount of protons in the nucleus. This atom has a neutral charge. This means that the amount of positively charged particles should be the same as the negatively charged particles. For this specific atom with 4 electrons, that means there should be 4 protons in the nucleus. What is the atomic number of an anion that has 5 neutrons and 4 electrons? Option A, less than 4, since an anion should have less protons than electrons. Option B, 5, since an anion should have as many protons as the neutrons. Option C, 4, since an anion should have as many protons as electrons. Option D, more than 4, since an anion should have more protons than electrons. Correct. An anion is a negatively charged atom. In order to be negatively charged, the amount of protons in the nucleus should be less than the electrons orbiting around it, or in other words, have more negative than positive charges. So there should be 4 electrons and less than 4 protons. The amount of neutrons should not differentiate an ion from an atom. It may define 2 isotopes of the same element, but that's another story, which I will tell you later. You have proved you can handle atoms like an expert. It's time for that important mission about life itself. Scientists like you sometimes need to survey a location and collect soil samples in order to formulate initial observations about how the soil may have formed and whether it could harbor life. Do you see where I am getting with this? Or more specifically, where will you be going next? Are you ready to contribute to the very controversial topic about life on other planets? I am about to teleport you to an exoplanet, and you will get a chance to explore on your own, collect samples, and come up observations regarding the presence of signs of life there.
I'm off to find the meaning of life.
Behold the beautiful yet eerie scenery of this exoplanet. In this hostile environment, the Labster rover is on a mission to determine if this planet is or was suitable for life. The rover's robotic arm can pick up rock samples. Now it is time to collect some rock samples. Click on the rocks in front of you.
Milo rover?
Good job. Let's teleport both you and your sample back to the lab. We have so much to do back there in order to investigate the exoplanet rocks you are holding.
I guess I found the meaning of life.
Take this rock sample to the workbench. Leave your rock samples in the bowl. The samples you brought back are composed of elements. Each element contains only one type of atom. I will perform a quick analysis with you to identify the elements present in the samples. Maybe they will provide some clues to help us succeed in our mission. The first thing we have to do is to identify the elements that make up your samples. That would help us start assessing if life on the planet is, or ever was, possible. I'm sure you have noticed by now the large periodic table on the wall. It contains all the information you need to describe the identity of any element. Let's try to identify the elements present in these samples from an alien planet. Click on the periodic table to move closer and interact with it. My advanced analytical machinery has found that one of the elements in your rock collection has 12 protons. Can you tell me the name of it after consulting the periodic table? Some elements are missing, but for the purposes of this simulation, you will find all you need in the periodic table in front of you. Option A, G, magnesium. Option B, P, phosphorus. Option C, potassium. Option D, no, sodium.
Interesting noises that the machine makes. Okay, 12 protons. Let's look at our periodic table. So the numbers on top often are considered, it doesn't say. It's the atomic number. So these more or less equate to how many protons an element has. So we're looking for 12. You'll see that it's Mg, also known as magnesium.
You must have played the periodic table simulation before coming here.
Sure.
Each element in the periodic table is defined by its atomic mass and number. The element with atomic number equal to 12 is magnesium, Mg. If the atomic number is 12, how many electrons are in one magnesium atom? Option A, 24 electrons. Option B, 6 electrons. Option C, 12 electrons. Option D, 18 electrons.
So again, protons equal to the same amount of electrons in an atom. So magnesium must have...
Ding, ding, ding. The atomic number of magnesium is 12 and represents the number of protons in the nucleus. The atom of magnesium has a neutral charge. Therefore, the amount of positively charged particles should be the same as the amount of negatively charged ones. As a result, there should be 12 electrons in the atom of magnesium, Mg, the same as the number of protons. The second element present in your rock collection has 26 protons but only 23 electrons. Can you tell what it is after consulting the periodic table? Option A, it is an ion of iron. Option B, it is... Option C, this element doesn't exist in the periodic table. Option D, it is a cation of iron.
So 26 protons, only 23 electrons. So that means our charge at the end of the day is going to be positive, since protons are positively charged. If we look at the periodic table, we see that 26 is iron. So since something is positively charged, that means it's a cation. If it was negatively charged, we would have had to choose anion.
That's right. This is an iron ion. It could be from ferric oxide. The presence of iron in such a high oxidation number could indicate the presence of oxygen in the atmosphere at some point. There is an element, aluminium, in the samples you brought back that can be found at the third row of the periodic table. How many neutrons does aluminium have? Hint, if you hover over the elements, you can see their atomic mass. Remember that the atomic mass is the result of the sum of protons and neutrons in the nucleus. Option A, 27 neutrons. Option B, 14 neutrons. Option C, 26 neutrons. Option D, 13 neutrons.
Aluminium. Sure, let's say like that. Let's find aluminium. Here, 13. So we see that the atomic number is 13, so it must have 13 protons, and the mass is 26.98. Just as it said in the hint, remember that the atomic mass is the result of the sum of protons and neutrons. So we have 13 plus a variable equaling about 27. So if we work backwards, we can say that we subtract 13 from the 26.98 to get our number of neutrons, which gives us 14. So it looks like they rounded the 26.98 to about 27. Kind of a trick question here.
There is one more identified element in the samples you brought back, potassium. How many protons does potassium have? Option A, 14 protons. Option B, 13 protons. Option C, 19 protons. Option D, 20 protons.
So let's look for potassium. Also kind of a trick question, considering potassium, the element is labeled as just K. So if you didn't know that, it might have taken a while to be shuffling through the entire periodic table, but you see that potassium has a 19, so it must have
Amazing.
19
Potassium
protons.
is in the 4th row of your periodic table and has the atomic number 19, meaning 19 protons in its nucleus. Fantastic work identifying these elements. You know that magnesium, aluminium, potassium, and oxidized iron were present in the samples you brought back from the exoplanet, among other unidentified elements. These elements have a story to tell, as long as you treat them the right way.
Interesting way to describe elements.
I hope you are not afraid to play with some chemicals that may shed light on our question. What is the life status of the exoplanet? But before we do that, there is one thing still missing from helping us characterize our elements even better. We have already learned that ions are atoms that are either missing or have extra electrons. Let's say an element is missing a neutron or has an extra neutron. This situation describes isotopes of the same element. The number of protons in the nucleus remains the same. Therefore, even though the mass number may differ, the atomic number remains the same for all isotopes. Are the atoms in this image the isotopes of the same element? Option A, no, since they have the same mass number. Option B, yes, since they have the same atomic number. Option C, no, since they don't have the same atomic number. Option D, yes, since they have the same mass number. Exactly. The two atoms above do not have the same number of protons in their nucleus, and since their atomic number differs, they are not the isotopes of the same atom. Given what you have learnt so far, the atom at the right is a cation, as it has more protons than electrons. Click on the Atomic Builder holotable to begin building your isotopes. When dealing with isotopes, it is important to keep the atomic number in mind. What is the atomic number of lithium? Check the structure of the lithium atom and click View Theory if you want to read the theory pages before answering. Option A, 3 since it's the number of protons. Option B, 7 since it's the number of protons and neutrons in the nucleus. Option C, 4 since it's the number of neutrons. Option D, 1 since it's the difference of neutrons and protons in the nucleus.
Remember, the number of protons equates to the atomic number, and since lithium is 3, that means it must have.
You are right. The atomic number of lithium is equal to the number of protons in the nucleus. Which of the following is an isotope of lithium? You can use the holotable or images to help you. Option A, a lithium atom with an atomic number of 4 and a mass number of 5. Option B, a lithium atom with an atomic number of 3 and a mass number of 7. Option C, a lithium atom with an atomic number of 6 and a mass number of 7. Option D, a lithium atom with an atomic number of 5 and a mass number of 6. Correct. For an isotope of lithium, the number of protons should remain unchanged and therefore equal to 3. In the image below, you can see in the column labeled as 3 all the isotopes of lithium. Tables like this one are called tables of nuclides and provide information regarding the possible isotopes of an element.
Okay. Took me a minute to understand how to read this table, but yeah, it looks like the highlighted number next to the element are the different isotopes of that element. So lithium 4 has a greater mass compared to its original, and then lithium 5 has a greater mass than a lithium 4, so on and so forth. So it's an interesting way to format this concept. I've never seen this table, but it's pretty neat.
Create an isotope of the atom on the holotable. Click the red Submit button when you are done.
So we know that lithium has 4 neutrons, and we want to make an isotope of that. One way we could just
Try changing the number of neutrons. We don't want to mess with the charge of the isotope.
simply adding another neutron would make this an isotope.
Good job. Now make this isotope and an ion. Click the submit button when you are finished.
So remember, an ion means negatively charged. Here we have more electrons than protons, so that means an overall charge will be negative.
You are right. You know, in a real chemistry course, an ion of lithium may not exist, but in a virtual simulation, many things are possible, like manipulating electrons and protons with your bare hands. Isotopes are important for understanding the evolution of other planets. For example, the different patterns of xenon and krypton isotopes on the surface of Mars give valuable insights to scientists investigating the reactions occurring in the crust of the planet. Click on the workbench to go there.
Really quick, one thing to note is how would we make this a cation? I know adding an extra electron made this overall negatively charged. So for a cation, it's more or less the opposite. We won't be adding protons because, again, that would change the element that we have here. So we would actually be removing electrons, because removing them would still net us an overall plus charge, as having 3 positives and 2 negatives nets us a positive charge. So when dealing with cation and anion, we are simply looking at the electrons here.
We have already talked about the basics of atomic structure, which are the subatomic particles that compose an atom, what is an ion, and an isotope. But how the electrons move around the nucleus and how all of them are bound together, it is another story. So far, you may think of all the subatomic particles as balls either being stationary in the nucleus, like protons and neutrons, or orbiting balls like the electrons do. Activate the left mini hollow surface on the workbench by clicking on it to see Bohr's atomic model. Bohr's model is easy to visualize, but it does not accurately reflect how electrons are spatially distributed around the nucleus, as they do not orbit the nucleus like the Earth orbits the Sun. A very significant chapter in science called quantum theory is describing the atomic model, and more specifically the complex shapes of orbitals, also known as electron clouds. These are the volumes of space in which there is likely to be an electron. Activate the right mini hollow surface on the workbench by clicking on it to see the quantum atomic model. As you can see, the electrons orbit the nucleus in a more complex pattern. This pattern is hard to visualize, so the scientists came up with 4 numbers, called quantum numbers, were introduced to describe the characteristics of electrons and their orbitals. These 4 numbers describe the quantum mechanical model of an atom. They provide information regarding the orbitals, which are regions in space occupied by electrons. These 4 numbers provide the identity of an electron, how and where it moves. Like identifying a traveler. Where is he going? Is he alone? Which route is he following? And which side road is he taking next? Would you like to know more about the quantum numbers? Option A. No, I just want to find out if there is life in the exoplanet. Option B. Yes, I want to know more about electrons and orbitals.
So because we're learning here, I'm gonna have to choose the option B. The meaning of life will have to wait.
I am so happy you are eager to learn. I spend so much time in this lab, and having someone to talk to about these things makes my day. A little bit of theory never harmed anyone. I will try to be as brief and clear as possible, as I assume you don't have a PhD in nuclear physics. The screen to your right will help you learn a bit more about the quantum numbers. Click all the Show Image buttons on the display to your right to learn more about the quantum numbers. The principal quantum number describes how much energy an electron needs to emit or absorb to change shells, which is a more complicated way to describe the orbitals you already know. The angular momentum number describes the shape of an orbital of an electron. The magnetic quantum number describes how the electron orbitals are oriented in space. Well, now that you have identified an electron and its orbitals, let's see if I could make a successful analogy with a traveler. Remember to activate your imagination. Click all the analogy buttons on the screen at the workbench to view the analogy. The traveler may walk on the short path if he doesn't have the energy to select a larger route and move further from the tree. The traveler may walk on a road with a different orientation. The traveler may walk with someone, but the other person has to be upside down to do so. If you look at your left, there should be a wall display next to the workbench. Each tab has a 2D visual representation of what one electron orbit may look like in a more realistic approach for each of your elements. Click on each element of the wall display to your left to see the quantum orbitals of one of their electrons. Why did the scientists have to come up with a different model after Bohr? Option A. Bohr assumed that electrons should lose energy and fall into the nucleus. Option B. Bohr's model did not explain the stability of the nucleus. Option C. Bohr's model did not describe the arrangement of electrons in orbit. Option D. Bohr considered electrons to have both a known radius and orbit. That's correct. Bohr's orbit interpretation was in conflict with the quantum uncertainty principle, which states that electrons can't have a well-defined position and velocity at the same time. Additionally, while Bohr's model worked well to describe the orbitals of hydrogen atoms, it could not predict the orbitals of electrons of larger atoms. But Bohr's theory didn't go to waste. Heisenberg, Zeeman, and many modern scientists have since enhanced the old atomic models with modern discoveries. I guess you are still wondering whether there could be life on the exoplanet. Remember, it is not about the destination, but the journey. You learned a lot today, and some of them will be used to answer our question. After all, I didn't teleport you to the exoplanet just to come back with jet lag. Let's see if we could explain the presence of life there from your data. Click on the reddish rock samples you brought back from the exoplanet. The red color could be the result of the iron oxidation, a chemical reaction that happens in oxygen-rich environment, Fe2+/Fe3+. During oxidation, iron loses electrons in a similar way ions differ from atoms. Pick up the pipette. Click on the beaker to collect a few drops of acetic acid. You need to have a tip on your pot. Click on one of the white rocks to add the drops on them. Leave the pipette on the stand. There is some gas coming out of your white rocks and looks as if a reaction took place on its surface.
Shouldn't this be done in a fume hood?
The acid just released carbon dioxide gas as the white rock contains carbonates. The carbonates naturally form in the presence of carbon dioxide and liquid water and could therefore provide important evidence for the presence of liquid water and possibly life in the exoplanet's past. Both the oxidation of iron and presence of carbonates provided valuable information. They both require the presence of water and oxygen to occur, and since they are very important elements for an organism to survive, I would say you may have a good reason to prepare your bag for another trip. Could this snapshot taken be true?
Is that a chicken?
Let me ask you one last question. Do you feel like you gained relevant knowledge during this simulation? Option A, completely agree. Option B, agree. Option C, disagree. Option D, completely disagree.
That's the end of it. Okay. Again, simple lab to do this week. And then exam was pushed back to the 22nd. And that's it. I'll see you guys next week.